to talk about something that has been in my mind for a while, and this is something we all struggle every day. And you're not going to learn something new today, but I hope you will go back with new energy to do things we know to do, but we often don't. And that's really my focus today, is to what are the things we can do to make our journeys better. So let me start by asking the question, how many of you are programmers here? Okay, that's cool, right? I'm in the right place, just want to make sure. How many of you have ever had an argument? Okay, cool. Let me rephrase that question. How many of you are married? Okay. Or how many of you have teenage children, for example? That takes the arguments to the next level, isn't it? So we all have had arguments. And when we have arguments, what really happens is we get emotionally charged. And when we get emotionally charged, a part of our brain quits thinking. Because it's not about what is the right thing to do. It's about what am I right about? And usually that's no good for anybody, including ourselves, when we have that argument. And so one of the things we often need to really practice to learn is to let go of that ego, but to really focus on why we are there. What's our intent? What's our purpose? And if we can get the work done and be effective in doing it, and that's what we're getting hired for, and that's why we are there in this profession as well. So what I want to talk about today is some of the experiences I've had and things we can do to improve the journey on what we are here to do at our work, and maybe not to go through those million arguments. And I'll just start with one example. I was here in India a few months ago working with the team, and there was a very good developer, and he suggested something, and I said, oh, that won't work. But I'm so glad he didn't listen to me. And he said, well, but I think it'll work. And I said, no, I don't think it'll work. But then I said, why don't you go try it? And he did, and it worked. And I'm so glad he tried it, because it doesn't matter what my argument is, because if it's going to work, that's what we want to do, keep moving. So there are reasons we believe some things, but how do we know if they're right? And to give that benefit of doubt that we could actually be wrong is a good thing, and that can benefit us a lot. So we all have gone through these million arguments over and over and over, where we endlessly debate whether we should be using one technology or another, or if the design should be done in one way or another, or if the syntax should be in one certain way or another. I mean, take anything for that matter. We seem to have all these things. And of course, the worst of all, should you use a tab or a space? That's not a discussion we're going to win, isn't it? So the point really is, we got so many reasons to argue every single day, but what can we do about it? So what can we do to eliminate some of these arguments and be productive with it as well? So I want to channel in the words of Hopper here for a minute. And she very wisely said, one accurate measurement is worth 1,000 expert opinions. So we all have opinions. We all have expert opinions on things. But what if we can look at the data? What if we can look at the results? What if we can do measurements? And if we can rely on those, then those opinions really don't have as much impact as the results we see. And what's really even more exciting is what may not work in a certain situation may actually work really effectively in another. And how do we know? And the worst thing, how many times have you seen developers and architects and leads do this? When I used to write code is a very dangerous word, because yeah, you used to write code 10 years ago, but the technology is different. Even the languages that you once knew are different. So what may have been good practice a while ago may not be a good practice now. So if we can demonstrate, that makes things a lot better, a lot easier. But this is the trait of us as humans. As humans, we are very good at thinking. And this starts very early on in the human development. You look at a little child, and the child, as the child grows and says things or does things, and you say, whoa, how do you think of that? So it's that part of that human nature to be able to come up with these ideas and think through things. That's very, really beautiful. But here is the irony of what we do. We're really very good at thinking, but not as good as thinking through. And we don't often think through the consequences of what we come up with. And what we think moves us forward. What we don't think through holds us back. Because when we don't think through things, we go forward doing things, and then that famous words, oops. And the oops is, gosh, I didn't realize that's not going to work. And we kind of get stuck with things. We're not sure how to proceed any further. And that can be really annoying, if not even be detrimental. Sometimes, things going wrong in production and so on. So what can we do about it? So as an example, there was this experience that somebody wanted to promote a really good idea. We should, develop children. Children have good practices. As a parent, you always are worried about, are my children going to do the right things? So somebody came up with this brilliant idea. What if we sell pencils, which has the really good message? A good idea. Great thinking, isn't it? Good thinking, but not good thinking through. Because what do you do when you use a pencil? Obviously, you're going to start using the pencil, you're going to write on it, and you have to sharpen your pencil. So when they sharpened the pencil, it said, cool to do drugs. And of course, when you start using the pencil a little bit more, it gives you the message, do drugs, which is not really what you wanted at all. It's quite the opposite of where you want it to be. So this is an example of the difference between thinking and thinking through. Because when you think of this, you say, wow, that's amazing. But what if when you start using the pencil, what's going to happen? And that becomes a bit of a problem, isn't it? Because eventually the slogan really becomes drugs. And that's not at all what you really wanted. And so, and every one of us have been in this situation in our lives, because you come up with this brilliant design idea, and then you end up having problems in production. And then you're like, gosh, how did I end up from being praised for a great idea? Now everybody telling you that's the worst idea ever, because that's not working in effect. So how can we really deal with it? So that's the whole point, is we are really good at thinking. We are not really good at thinking through. And so how can we save our, efforts in the thoughts we had and make sure it actually will work all the way into production and be valuable? And that's what I want to talk about today, is things we can learn from our own experiences, but from experiences of others who we consider to be the experts and these amazing people in the history of our humankind. So let's talk a bit about a few things. Now, this is a theory I've had for quite a while. And my theory is, those who design the bathrooms in a hotel have never showered. And I can prove this to you. And I'm in a hotel, I go into the bathroom, and I say, do the people ever shower when they design these bathrooms? Because you get into the shower and you're like, how do I use this? I can't tell you how many bathrooms I've been in a hotel where I hit my hand every corner I turn. Or sometimes things don't work. They're too hot, too cold. Everything possible. And you think you have covered everything. But this is a hotel in Montreal. I was there a couple of years ago. I'm not even exaggerating. I just had to take a photo. When you're angry, you don't shower anymore. You tweet about it. And so here's a photo I posted. This is literally the shower. Does anyone see what's missing here? Where do you put your soap? There was no place to put the soap. So I walk in with the soap, and now I'm spending 5 minutes designing how to really have a soap while I shower, so the soap doesn't get all wet and soggy. And I'm trying to say, is this a puzzle maybe they built for me? Maybe this is not a showering activity, but an IQ test built into it, right? So I went down to the front of the front room and said, excuse me. And she's like, yeah. And I said, the bathroom. And she's like, don't even talk about it. I said, seriously? She's like, yeah. And so it's not just my room. It's like, no, the entire hotel. They forgot to put the soap, dish. I'm like, seriously? And this is one of the theories that I've developed over time. The people who use the software make the best software, hands down. If you're a user of a software, you make the best software. If you are developing software for somebody else to use, there's a complete disconnect because your focus is on coding, not on usability. And so, as an example, I have a Rivian. Rivian is an amazing engineering. I love that electric vehicle. But a few months ago, I was complaining that when you get on the freeway, and most of the freeways I drive in, we can drive in at 75 miles an hour. That's right. I apologize for you. I did say miles an hour, not kilometers. We are still used to barbaric units. Unlike you civilized people who use better metric units, I don't even have a clue what that is in kilometers, so I apologize for that. And so I want to get on the freeway. I want to turn on the cruise control, and then it would put it on the speed at which I was. And then I got to keep pressing the button to go up in speed. And I was telling my son, this is kind of stupid. And then a few months later, there was a software update, and you get on the freeway, you press a button, and they realize what the speed limit is because they have the data, and they immediately speed up to that particular speed limit. And I was telling my son, hey, this is really cool. And he said, yeah, Dad, that's what happens when software developers actually use the product they are developing. Because that's a thought I had as well. And same thing, the people writing the code said, that's kind of stupid. We got to fix it. And that's the beauty of a person who can develop the code can actually fix it when they're a user as well. I think very few fields can actually do it. I don't think dentists can do that to themselves. I'm a dentist, right? That's not going to go end well. Maybe accountants, I don't know. But very few professions can actually fix the things they need. And that's the beauty of our field, is if we are a user of a product, we can do better as well. So that's one thing I always complain about. The same thing, I love this room, by the way. I love this room. But I cannot tell you in how many conferences I'm in. They will place the screen so that nobody can see it. And what's the point? And everybody's like doing this to see the screen. So I also have a theory. Those who designed the rooms never actually learned anything. And that's true, actually, from what they produced. So this is something we want to think about. How can we really think about the consequences of what we design? I came across this very recently. There is this door I saw, and a great idea. When different people work on different things, we want to think about what's the consequence of it. So here is a door, as you can see, and the design was very purposeful. When you open the door and enter the room, you want the door to shut automatically. So they have this little device that's going to close the door as soon as you step in. But the person who designed this did not communicate with the rest of the people. So as a result, it left a huge hole on the wall. And you're like, what just happened here, right? So clearly, there was no communication. Clearly, nobody thought through. And of course, when the person opened the door, there was a oops. And what do you do about it now? It's a little too late. So the point really is, again, thinking versus thinking through, we got to be careful about it. So that becomes very important. So the question then is, what is the consequence of what we design, what we create? As it turns out, what you don't know can actually hurt you. This is one of the problems we live in. It's the fear of the unknown. But it's not just the fear of the unknown, but the consequences of the unknown makes a big difference as well. This comes down to the story of Vasa. I was in Stockholm last year. I was walking through the museum in Stockholm, and they have this beautiful museum built around the ship called Vasa. This is not Vasa. This is a model of Vasa. And that beautiful ship was designed in, this is the model of the ship that was designed in the 1600s. And the ship was designed by one of the most renowned architects of that time, Henrik Hybertson. And Henrik Hybertson was considered to be the best architect in Sweden, in Europe at that time. The emperor of Sweden wanted to show his might. He wanted to show that he is the most powerful king. So he hires the well-renowned architect and says, you will build a ship that will scare the heck out of anybody in the world. And unfortunately, the architect did not know to say one thing. Remember that famous phrase, the emperor is not clothed. And the emperor said, you will build the top deck and you'll put all these huge arteries on it. Well, guess what? Nobody really had done that ever before. There is one thing I've realized in life. If you ever disagree with physics, you know who's going to lose. Because physics always wins. And he said, I want all of this on the top deck. And the, architect tried to tell the king, excuse me, that would not work in law of physics. There's this thing called the center of gravity. And the king said, I'm the center. You have a next question for me. So what do you do when the king says that? You just build what the king wants. And so they built it, and they put people on it, obviously. And it took its very first sail, and it drove 1,400 meters. You say, wait, you use the metric unit right now. Yes, that's because that I read it from the Sweden website. They use civilized units like you do. So that was 1,400 meters. It sailed, and that's all it did. And went right to the bottom. And that was in 1600. In 1960, they eventually developed the technology to pull it out, and they put it there for 17 years to cure it. And then they made a museum out of it. And about 160 people died on that day on that ship, which is extremely sad to know about it. And what's even worse is nobody was punished for this. Why? Because when the king makes the mistake, who do you punish it? So the point really is, this is an example of when we do things when nobody has ever done before. So how many times have you seen this on software projects? Hey, we got to use this technology. Has anyone used it? No. Have you built microservices? No, but we love it. We don't know why we love it, but we want to build it. And we jump on it, and we're infatuated about it, and the result is a disaster, and we are not, and it sinks like this ship. So the point really is, if nobody has ever done this before, why would you want to build it without knowing if it's feasible? So is it feasible? Will this work? Have you built something to that scale? Have you built something to that performance? Have you built something to that particular set of features? Is the team familiar with it? It doesn't matter if somebody else has done it, but has your team actually spent the time building it? And with this group of people, with this group of users. So in other words, we have to really ask the question, so our products don't end up like Vasa, how can we really be careful about it? This also brings up, I apologize for the things being cut off right there because of the resolution. So here is another example we can learn from. This was back in 1940s. They wanted to build a bridge across the Tacoma River, and they wanted to build a narrow bridge for auto to drive over. So this bridge project was started. They had never built a bridge like this before. And the people who were building the bridge at the time were so eager they got the contract. And they were a group, and of course, the problem is, in a lot of these parts of the United States, you can have extremely high wind. I live in a place which I feel like I'm in a windstorm almost 90% of the time. You step out and you're like, ooh, what's going on here? And so there's a lot of wind, and you don't know when there will be a wind. And so there were people who were very curious about this particular project. And guess what they did? They built models of the bridge, and they turned on really high-powered wind tunnels on it, and then they blew on the bridge, and every single model fell apart. And they were like, excuse me, we built models, they're all falling apart, you guys are building a bridge. Do we want to think about it? And they were told, well, you don't understand math, do you? Well, the problem is their math was wrong, but they would refuse to even consider this. So they went ahead and built this particular bridge, and guess what happened? Let's take a quick look. I won't play the entire video here, but I want to just show you a couple of little things that you can see here in terms of, what it's going to do. So let me just go back here and try this one more time. So let's try this one more time. So I want to show you a little example of what happens when we don't listen to things like this, and we try to really build it, and what a disaster it could actually be, if you will. So looks like my internet connection wants to bail out. Let's try this one more time. So essentially, this bridge they took the time to build it. And of course, once they finished it, they inaugurated it, they celebrated it as one should. And once they finished it, it was used for traffic for a little while, but a total of 4 months is all this actually stood up. So let me try this again. So it stood up for about 4 months in all, and unfortunately, that's all it could last in its lifetime. So let me try this again. So right there is the bridge being constructed. Let's take a look. And like I said, I won't play the entire video. So they had built it, and they had inaugurated in May 1940. That's a construction you can see. They had, held the celebration of inauguration. That was fantastic. And then a few months later, the bridge started really swaying. And of course, when something is really broken, what do? You don't stay away from it, right? So there were people who were trying to walk on it because how cool that would be. And so you can see maybe a ghostly figure in the middle that this person is actually trying to walk. I apologize for the quality of that video. That's from decades ago, obviously. And of course, somebody tried to even drive a car on it, and there's a person walking on it. And that didn't go really well. And eventually, of course, because of the wind, it did not stand, and it fell apart one fine day, 4 months after it was built. Again, a lesson we can learn from quite a bit is, what does it mean to build something of that scale, of that magnitude? And there was one day when there was a lot of wind, and it just took its last, swaying. And of course, somebody was, measuring the time it is taking for that little oscillation, and they found it was a 5-second. So do the math. So that is again something for us to think about. How do we really build something of that scale? How do we sustain it? But of course, I always tell people I make a lot of mistakes. I want to absolutely convey that to you. I'm not trying to pretend that I'm actually good. I'm actually really bad. I make a lot of mistakes. And these people also made mistakes, but there's one difference in everything you see here. When they make a mistake, it ends up on the news. When I make a mistake, exactly 3 people know about it: my wife and my 2 children. So that is the scale, again, we are talking about here, right? So it's very unfair, I know. But when it ends up on the news, we all can learn from it. We can really relate to it. So this was an experience in France, and their railway system was very different a few years ago. The people who were responsible for the tracks was a different company than the company that was responsible for the trains. This is very unfamiliar to us, right? Because we all have one team that does everything, right? Our QA is, in-house. Our developers are in-house. We talk to the users every single day. Well, you know what I'm talking about, right? So they had the department that runs the railway tracks, very different from the departments that run their trains. So they ordered 2,000 trains for new, beautiful trains. And when they built out all these trains and they brought the trains over, is when they found out that of the 8,700 train stations, think about this for a minute. Of 8,700 train stations, 1,300 train stations were too small to fit the train. Imagine you are the driver of the train. You are riding your train the first day, and you're looking at the platform, and you hit the brake, and you realize this train won't go into the station. And so they had to shave away the platforms to widen the platforms so the train can go in. That cost them $68 million. Now imagine, oops, we only did not plan for that $68 million that we have to spend to break the platforms and widen it. So how could we make such a mistake? But to make things even more interesting, the French government covered this up. They didn't want anyone to know about it, right? Don't talk about it. Let's just expand these, until a particular magazine journalist kind of went around and said, why are they shaving off these platforms in these different stations? And then this whole thing blew up. Again, To that magnitude, how could we fail so big? What did we do wrong? What if you had built one train and sent it around? What would you have discovered rather than building 2,000 trains? Something to learn from. Again, have we all written a lot of code and saying it'll work? And what do you ask the programmer? Are you sure it'll work? What do they tell you? I hope. I hope. That's called hope-driven development, right? Hope-driven development is amazing. I hope it's going to work. Very scientific, as you can see, right? And we just have a bucket of hopes every morning, and we just take it out a little bit more every day, make sure they get to refill it overnight. We got a lot of hope on it. Hope is great, but I think we need something more than hope. So that's something to think about. So what you don't know can really hurt. So when I write software, what I want to know very quickly is, what is it that I don't know? Because if I live with what I don't know, that's what is going to come and hit me in the back. And I want to know what I don't know. The sooner I know what I don't know. But how do you know what you don't know? You don't know that by talking about requirements over and over and over. You don't know that by just sitting around and talking about things to developers and users. When you start building things and when you start using things, you get to know the reality of things very quickly. So the faster you can get to it, the more feedback you actually end up really getting over time, so that can be really useful. So there are many unknowns that we constantly have to deal with. And our life as developers is really working with these unknowns every single day. Now, one of the things I often encourage my developers to say very boldly is, very boldly say, I don't know. We should be open to accept, I don't know. We have this tendency sometimes, hey, maybe if I say I don't know, that's a reflection on me poorly. But I would say it's quite the opposite. Because if you say you don't know, you're opening it to going and finding what you need to know. And that really tells us we got more work to do. It brings more reality to what we are doing. So be open to say, I don't know. That's a good thing. So we want to think about these unknowns. So what are we creating? And software development is that business where we create things, but it's not like a predictive manufacturing, where you're building one more of this product. When you're developing software, you're trying to understand the nuances of this software you're building. So there's a huge amount of unknown. And even if things are given to you, there are things you don't know. I'll give you an example of this. I was a consultant on a project where this company was rebuilding an existing product. So this was in the market. It's been around for 10 years. And the company said, it's old technology. We cannot support it anymore. We're going to rebuild it. So I'm the new consultant. I was not involved in the previous project. The team had developers who have been there for a while. And the president of the company was in the room. This was a very important project for them. And I was looking at requirements and I said, why does this requirement exist? And the immediate answer was, well, we need to implement this because it's a feature in the product. I said, well, thanks for that response. But why is this feature in the old product? And somebody said, that's a requirement. I said, why is that a requirement? And one guy rudely said, what part of that's a requirement don't you understand? And when people are like rude like that to you, how do you respond? And thankfully, I didn't have to. And the president of the company who was in the room said, hang on a second, answer the man properly. Why is that requirement there? Is there anyone in this room who can answer that question? And nobody could. You are implementing this because it's there in the old product. And I said, folks, I'm not trying to challenge you. I really don't understand why you would have this feature. And if you're going to take the time and money to implement it, I need to know why you're implementing it. And the president of the company walked to the front of the room and he said, how many people in this room know that we get 60% support call for that feature? And I was like, whoa, this was lucky to have landed on one thing that's such a mess. And he took a marker, put a little box around it, crossed it and said, this will not be implemented. And it is to take the time, what are we creating? But I'm a mere mortal human being. I struggle to learn. I doubt myself a lot. So I want to ask, what do great people do? Do they walk on water? Maybe I'm the one who has trouble navigating this landscape. So I kind of looked up back into the history. What do the great people do? So there is this amazing painting, a renowned painting in Spain, and this was developed in 1659. And this is an extremely popular painting, Los Maneros, and they wanted to rebuild this. And Picasso said, hey, I'm going to recreate this painting. Of course, as we know, the style Picasso uses. And so he said, I'm going to recreate it. And you would say, well, it's Picasso. It's going to take him maybe one afternoon to paint this, right? So he can walk in, look at this and say, got it, I'm going to paint it. But Picasso wanted to do two things. He wanted to make sure he preserves the originality of that painting, but at the same time, he wanted to bring his own style into it as well. So guess what he did? He did not create his own masterpiece. Instead, he spent time creating over several years 58 versions of it. 58. How many times you write code and the next voice in your head is, am I done? Can I ship it? And he said, I'm going to create 58 versions of it. So he sat down for 4 years, created 58 different prototypes of it. He even spent the time creating a much focused version of just the master icon in that painting. And these are all 2 of its 58 prototypes. In the museum in Barcelona, they got all the 58 along with the final masterpiece as well. If you visit Barcelona, make sure to go take a look at it. It's one of those rare where they never just kept the final product, but they kept the prototypes as well. So a lesson to learn is taking the time to take this time to create it. This was the final thing he created. This is what we often say, wow, but there were several things before that. So to me, the wow is not just this was created, but all that prototypes that was created along the way as well makes a huge difference too. To what scale are we trying to develop? And oftentimes we think about performance, we think about scalability, but what are we doing? Have we created something of this scale, of this performance before? That's a question we need to ask as well. And again, something we can learn from experiences. This is an amazing monument. I've been there maybe 3, if not 4 times. I do have to tell you, if you ever go to Mount Rushmore, I always look for things that excite everybody, but there are a few things that excite me as well. So if you go to Mount Rushmore, if you're driving on your way back, there's a very small tunnel. And as your car drives through the tunnel, I always slow down. And thankfully, there's not much traffic. And I would look through the rear view mirror in my car, and through the darkness of the tunnel, you see Mount Rushmore just at the distance. It's one of the most beautiful things ever I've seen in my life. So I just drive there just to see that little Mount Rushmore through the tunnel, if you will. But think of building something like Mount Rushmore. How do you build something like this? And guess what? You don't have much option for. Whoops. Because that's a mountain. You oops on it. You're not going to say, can we do a git rebase? Can we get this mountain back, please? We want to build again on it. So this is the funny thing in our field. Everyone else in the world dies to have the luxury we do. You commit, you rebase, and you move on. And yet, we are so reluctant to do it, right? Everybody else is like, can we undo this? They're like, no, you can undo a destruction you create on a mountain. So, as ironic to the word Rushmore, there was no rush in creating it. They did not rush through this. So, in creating this one, it turns out that the person, the architect behind it, started building prototypes. And when he started building prototypes, you can see one prototype there he is creating that's about his size, nothing really to the scale, obviously, to the big structure. And he was having the president's face in different directions. They had different clothing on them. So he had a lot of vision as to what they should look like. And then he built several of those prototypes. And this work went on from 1927 to 1941. That's a long time. He actually died in 1941 before this was completed. His son actually took the project and finished it that year. So this was a work he had done for a long time. And by building all these prototypes, he got a vision as to how it should really look like. And in the meantime, he examined the actual rock formation of where this is going to eventually get built. You can see this one, he's on a ladder. This is much bigger in size. And you can see this is getting closer to what was there eventually. But what he found out was that the rocks had cracks in them on the mountain. And the rocks were different in structure. So he couldn't build things the way he wanted to build them. So he had to redesign what he wanted to build. It doesn't matter what you wanted. The mountain tells you what you can have. That's the beauty of nature. The nature doesn't care what you want. You better want what the nature tells you that you can have, right? So as a result, he had to redesign his mountain, his monument to fit the mountain on which he wanted to build it. That's another example of what is needed is to keep prototyping it, to learn from it. That becomes really necessary. So we talked about knowing what we are building. We talked about scaling things to the level we want to scale. And every one of that is a concern we deal with every day in software. But a third thing we need to worry about oftentimes is what's your risk? Because risk is what separates the winning business from the losing business. Because a winning business handles the risk properly. The losing business couldn't recover from it. They're not resilient from it. So how do we deal with the risk? So I came across this as I was going through Switzerland last year, and they were telling me about a company that got into a contract. And the contract they ran into was they were required to build a network that ran 200 kilometers. Imagine that. I don't know what 200 kilometers is. You know that better than I do. If this was in miles, I can relate to it. But I'm going to say 200 kilometers is maybe half the distance between here and Chennai. Is that reasonable to say?
Here to Mysore.
So, here to Mysore? Thank you for that. I appreciate it. So from here to Mysore, that helps us, right? So from here to Mysore, you want to build a network. And the requirement was that it needs to have a certain performance. And if that performance is not met, you are really in high risk of not meeting the SLA, and the contract penalties were extremely high. What would you do, so to use the word, if your lifeline depended on it? So they were struggling with it. How do we prove that this network performance is going to work for a 200 kilometers network? So they finally figured out there's only one way to really manage that risk. They brought in 200 kilometers of network into their office. And within their building, they built the entire network with coils, which I don't think I can even show to the magnitude how to achieve that. And they built coils upon coils upon coils within their office, and they made sure this was actually working before they rolled it into that 200 kilometers. So imagine one building where you got 200 kilometers of cable that you built. But if you really think about it, right, we often worry about things in software. But look at our friends in NASA and other space agencies. They're spending missions to places where humans have never, ever been before. And of course, we also know about Mars rover. They forgot that there's a difference between kilometers and miles. Like the struggles I have, they're not any different from us, except their mistakes are well known than ours. So how do you know this is going to work? That becomes very important. And how can you really validate this as well becomes a concern. Now, I think we all complain about our lives. We complain about how terrible our job is. We talk about, oh my gosh, you know what happened when I had a memory leak. But there are people who do some work that just blows my mind. It humbles me. I can never stand in front of them and say, when they say, what do you do? I say, never mind. It doesn't matter in front of what they do in their professions. One such thing is Dr. Marshall. He is 72 years old now. I just will tell you this before we go further. He is well and alive. And this was back in the 1980s when he was in his 40s. Dr. Barry Marshall was interested in finding what caused ulcer, peptic ulcer. And at that time, I'm sure you have heard about this, right? And they were talking about what causes ulcer. He got eventually a Nobel Prize for this. But at that time, the prevailing belief was ulcer was caused by stress, spicy food, and too much acid. I got angry reading the word spicy food. That's what I live on, right? You can't take spicy food away from me. I would live with ulcer, but no less spicy food. Scott knows about this very well, right? So essentially the idea is, this is what they believed. So they would say, you got ulcer, quit eating spicy food. I'm like, are you kidding me? That's not going to happen. Well, thanks to Dr. Marshall and Dr. Warren, they had a hunch. They thought, yeah, it's not the spicy food. It's actually a bacteria that is causing the ulcer. And everybody said, nonsense. Why? Because bacteria cannot grow because your stomach has acid. My argument is quite the opposite. Spicy food cannot do anything because there is acid. Spicy food is more acidic. So the point really is, his argument is, hey, it's bacteria. They said, there's acid in the stomach. Clearly, bacteria cannot do it. So what do you do when the theory you have is opposed to the theory somebody else has? How do you prove this? He tried to experiment on pigs, logical, and that didn't work. So he was really desperate. So he wanted to prove this. So he went and got some funding for a year, and he decided to experiment. And he went to his lab technicians and said, take these bacteria, put them on acid, see if they grow. And they did 30 experiments, 30 of them. And every one of them failed. What do you do when 30 experiments fail? You're like, oh my gosh, yeah, thank you for that feedback. I love that music, the direction behind, right? Yeah, that's how dramatic it is, right? So, oh my gosh, what do you do when 30 experiments failed? Maybe these guys are correct, that bacteria won't grow in acid. Well, it turned out the lab technicians, remember, they're there to do their work. And they were told, take the bacteria, put it in acid, turn the clock on, and they had a lab to maintain. So every 48 hours, they would clear the lab, and they would start over the experiment. And so 30, experiments proved nothing. And the lab technicians, thankfully, got a little busy. They couldn't clear the lab on the Thursday. And they said, yeah, 30 of them failed. What good is it? Let's clean this up on Monday. So they just left it for the weekend. They came back on Monday. They was about to throw this away. And they looked at it and they said, whoa, notice what's there. There is bacteria. And the 31st experiment showed bacteria. And that's when they found out, unlike normal bacteria, this particular bacteria took more than 48 hours to grow. And the lab experiments never gave them more than 48 hours, so they could never prove it. And since then, they did 100 experiments total, and all but the 30 gave results the bacteria was growing. And so guess what they did? They published this on a paper and said, ta-da, look at this. The bacteria does grow, it just takes more time, and so that's what is causing your ulcer. And the medical journalist reviewing the paper said, nonsense. We won't accept it. It's got to be the spice. Acid, it cannot grow. So he was sitting there thinking, how in the world do I make people realize this is what's causing the problem? I'm not recommending this you do. I don't recommend this to anyone. But this to me is amazing to think about it. He realized the only way to prove it is to self-ingest the bacteria on himself. Really scary thought, isn't it? He took the bacteria, and 3 days went by, and his wife said, "You smell funny." And his wife found out he was sick. And that's when he proved to the world that ulcer was being created by this bacteria. He had ulcer for himself. And they eventually had to cure him. And of course, he's got other things that went on fine for him. What an amazing, amazing way to prove that things actually work. And then you go to your programmer and say, "Can we do a prototype on?" "I don't have time for it." Seriously? Think about that for a minute. So he self-injected this bacteria, and his wife noticed he was sick, and they found it. So is it feasible? Can we actually do this? So I will relate to this with my own experience. This was 30 years ago to the date, almost. This was one of my very first programming jobs, 30 years ago. And when you're a very young programmer, you haven't ever written production code, you're sitting there and working, what do? You feel like you can do anything and everything, isn't it? Because when you know the least, you have the most confidence. So at that time, we were using an object-oriented database called Versant. And I remember this was Versant 4.0. They had just implemented into this object-oriented database what's called optimistic locking. Well, it's optimistic locking. And they said, "Do you want to use it?" How could you not be optimistic using optimistic locking? I said, "Yes, I know how it works. I've been through that training. I've read it. I can do it." So I implemented optimistic locking on my application. Remember, this is the first time the database has optimistic locking. Nobody in the world has used it. I was one of the very first person to apply it on a large-scale project. And we finished development. I made so many code changes, and I was very naive, green behind my ears. And now, 2 days later, one of my team members comes and says, "Did you notice we lost some data?" "Oh, maybe there's a mistake in the code." We spent a week finding what the problem was. We couldn't find anything. We took a version of the code which did not do optimistic locking. We ran it. It worked fine for the same example. The version optimistic locking doesn't work. So what do you do now? Imagine this. You're a programmer who is relatively new. You got a code base where, oh, by the way, I forgot to tell you, we had 7,000 C++ classes in this application. So I'm sitting with this large code base in front of me, and the only person who has implemented this code is this guy, little guy. And my boss comes to me and says, "So how's it going?" "I'm trying everything I can. Seriously, I don't know what's going on." And what is the worst thing you want to hear when things are not going well? Your boss telling you, "I know if anyone can do this, you can." Like, stop, leave, go away, right? And my boss is like, "I know you're really good. Please stop that." I could not figure out what was going on. A month struggling with it. And I'm calling the database vendor. "Versant folks, can you help me?" They said, "No problem. Send us your code." Which code? I've got 7,000 C++ classes. Before it can leave this building, 7 attorneys have to talk about it. I got to get permission from them to release this code out of the building. It's not going to happen. It's proprietary. So what do? And I learned my lesson the hard way. Oh, by the way, eventually found out what the problem was. It didn't work. They issued 4.1, which said, "Bug fix for optimistic locking." I'm like, what? I put the bug fix, my original code actually worked. I did nothing except crying for a month. Because there was nothing I could do to fix the problem, because it was not my problem. But what was the problem? I didn't know it was not my problem. I learned my lesson the hard way. I said to myself, Venkat, grow up. This is not the way to develop software. Fast forward 10 years later. What is experience, right? So that is the beauty of being experienced, isn't it? So I was on a project when the client said, you will build this product with this UI toolkit, which I've never ever heard of in my life. I don't know what this toolkit is. I said, this toolkit, oh yes, you need to use it. Are you sure? Absolutely. If you cannot use it, let us know. We'll find somebody else to do it. That was the conversation I had. I'm like, oh my gosh. Then I did a little convincing them. I said, I want to succeed on this project, so do you. So I promise you, let's build it with the toolkit I know, clearly mentioning in the contract. I will spend all the time and money converting the code to the newer toolkit. The minute I get access to it, learn it and apply it. They said, only if you promise to do it, written in the contract. So we started building application, but what happened in the meantime? I built their trust. Because every week I was sending them the product for them to use. We're finding bugs on their end using this tool already. So they were like, this guy is actually doing stuff. We have confidence in what he does. And I got the product, learned it, and I said, let me integrate it. I'm like, do you remember the last time you did something like that? Heck no. So I left the project, went to a separate, completely different directory, recreated a little example that mimicked that particular part of the UI. Our UI was drawing literally tens of thousands of things on the screen. I just created a hello world equivalent of 10,000 things on the screen to display. And my application written, real code written using the toolkit I know, was blazing fast. This little prototype with nothing else. All that you do is you fire it up, it's just drawing stuff on the screen. And you can sit there and watch it. Oh, there's one. There's one, there's one. I'm like, I'm doing something wrong. I spent 3 days debugging. Didn't work. So I called the vendor and said, excuse me, can you do me a favor? I'm using your product. It's not working. Clearly, I am doing something really bad. I need your help to look at the code, and in 5 minutes, you can tell me I'm stupid. But I just want to know from you that I'm stupid, just to reconfirm that I'm actually stupid. Oh, we'll be glad to tell you you're stupid, send it to us. So I sent it to them, and they called me within 2 hours. And they said, you're stupid. I said, yes, I know it. And I said, what was wrong? And they said, using our product. I said, what? And they said, why are you using our product? I said, what do you mean? Don't you want your product to be used? And they said, not like this. This is not the intended use case at all. This is not what you're supposed to do with it. Who gave you this bright idea? I said, can you do me a favor? Can you put that in the email? Tell me I'm stupid. They said, we love doing that. So they sent me an email. You're stupid for using this. Thank you. I went to my clients and said, hey, folks, I just want to talk to you about this. I'm going to make the port next week. But I want to guarantee you one thing. It's a one-way port. I'm going to port it once. I'm not going to report it. But before I port it, I just want you to look at this demo. And I want you to look at this email from the company. But it's a contractual agreement, architectural requirement. Just want you to know it. They called me on the phone. Stop. What are you doing? Well, I need to port this over to this because that's what the contract says. Are you kidding me? We don't want that performance. Hey, but you said you have to use the tool. Oh, we don't care about the tool. We just care about the performance. Then why did you tell me you have to use the tool? Oh, we don't even know what the tool is. Somebody said it's a great one, so we decided to use it. I'm like, oh, that's how you do architectural decisions. Thank you. I learned another lesson. So the point is, when you've never done something, just don't do it. It makes no sense. That's what I learned the hard way, and this really rescued me. So the code always does what you type rather than what you meant. But what did we mean? We sometimes don't even know that. We need to understand that over time and figure it out. So I go to developers and I tell them, let's do test-driven development. They kind of look at me like, what? I tell the same developers, let's implement code. Boom, the code is done. The same brilliant programmers, I say, write test before you write code. They're like, are you out of your mind? How do you write code before writing, how do you write test before writing code? And I was kind of puzzled by it. Why do these brilliant programmers who can write really good code have trouble writing tests? And it finally dawned on me there's a reason for it. We all do programming, but how do you write programming? Do you ever go to your desk and say, I'm going to write this code, and then you just sit there, type the code, and it works? Does that happen to you? Never, right? You write some code, and you're like, huh? You look up Stack Overflow. That doesn't help you. Does Copilot help you? ChatGPT help you? Sometimes it makes things worse. You call your colleague, they give you 7 opinions now, you're more confused, and you're like, I don't know what's going on with this code. And eventually, it seems to work. And you quietly leave it and step away, right? It's like, don't touch it, I want to go home, right? What do we call this? Programming, right? If others know what programming is, they will never trust us to do this. But this is our little secret in this room, right? That's what we do for a living. So programming, what is it then, really? Programming is a series of mini experiments that lead us to discoveries that help us to transition from a set of unknowns to a set of knowns. That's what we do. What is programming? Programming is not typing the code. Programming is to understand what the freaking problem is. Because I don't even know what I'm doing until I start doing it. And I'm like, whoa, that's what we were supposed to implement. Because when you start writing code, something funny happens. You can run it. When you run it, you can complain about it. And now you can start changing it. So when I tell programmers, write tests before I write code, they're like, are you kidding me? I don't even know what I'm trying to write the code for. So what do? So here's the lesson I learned. If I know what I'm doing, I write test and write code. A lot of times I don't. So I leave my code alone. I go create a very separate prototype. I play with it. I learn how it works. And then I say, cool. Never tell anyone you wrote a prototype. Because if they find out, they turn your prototype into product without any test. So never tell them that. Be quiet. Don't say that that works. And if you have worried, delete it. Print a copy of it on paper and delete it. So at least somebody has to type it back if they have to, right? And then come back to your code base. Now you know a lot more about this problem. Write test, write code, write test, write code. So the idea really is learn to prototype so you can prototype to learn. It takes a certain amount of skill to start prototyping too. But first learn to prototype and then prototype so you can learn how things actually work. So that gives you the confidence to be able to come and write the test cases as you move along. So we feel like we got one shot at writing the code oftentimes, and that is very misguided. That's not what Picasso did. That's not what the person who built Rushmore did. That's not what anybody who ever does anything of value do. They don't do it once and walk away. So why should we then? We should develop the sense, the discipline, and the culture to know that we got to experiment. We got to create things. So essentially, we often compel ourselves to get it right on the first write. But that is naive. That is illogical. And we should change the culture that drives us towards doing that. It doesn't make sense to drive ourselves to what is impossible. So we often hear about things like FOMO, but there's something else that we often, that afflict programmers. It is the fear of, or maybe it's rather a reluctance to try things out. But that's a culture we want to change. So take the time to try things out. We need to experiment. We need to prototype a lot more than we allow ourselves to do. You don't need permission from others to do it. It's a permission you give to yourself for you to be able to do it. You need to empower yourself to do it. So experiment or prototype to learn, to understand, to isolate the issues from the surroundings, to validate, and to reduce the risk as well. And these are the reasons and more that we need to really take the time to experiment, take the time to prototype. An experiment either confirms your assertions or it clarifies your understanding. But in both cases, you come out winning. There is no loss here. Either you know more or you know that you knew more. And in both cases, you come out winning. So let's get out there and win and succeed doing it. And I hope that was useful.